episode, you will learn about how gravity affects the orbit of objects in space and how this impacts the operations of Spacegate Station as it maintains its orbit around the Moon. You will also learn the process involved in keeping Spacegate Station in its orbit and the mathematical computations related to this process.
Affirmative, Mission Control. We confirm the arrival of the resupply ship Defiant. Mission Commander Collins has advised they have hard dock and will be offloading shortly. Yes, I will make sure she contacts you regarding the navigational update data for the return voyage. Spacegate Station out.
Specialist Barber, the automatic unloading sequence of the resupply ship has initiated. It will take approximately 1 hour, 43 minutes, and 32 seconds to complete the unloading sequence.
Okay, thank you, Aurora. I look forward to seeing Commander Collins again. We still have that Space Monopoly game to finish.
Monopoly is a board game in which players roll 2 six-sided dice to move around the game board, buying and trading properties, and developing them with houses and hotels. Players collect rent from their opponents, with the goal being to drive them into bankruptcy. Money can also be gained or lost through chance and community chest cards and tax squares.
Yeah, Monopoly. I remember that game. It takes forever. Now, not to mention you're only seeing your opponent, once a month?
Yes, but in Space Monopoly, you try to take over the universe, and you get to explore strange new worlds, you get to buy planets, you get to set up space colonies.
Yeah, like I said, it's a boring game. I mean, you've taken an hour and a half Earth boring game and made it into a 9-month boring space game.
Excuse me, but I will have you know with Space Monopoly, it's the quality of the game experience, not the quantity. This is not beat the clock,
Specialist Barber, I am confused. I do not understand why you would commit violence against an inanimate object like a clock. To do so would be a violation of NASA Policy 12.65 on the misuse of station equipment, and in addition would be a demonstration of poor anger management. If you like, I can suggest several articles and a very informative documentary to help you with your control of your anger issues.
What? I do not have anger issues.
I am detecting elevated levels of stress in your voice patterns, which would be consistent with the emotional state humans experience when angry.
I wonder why.
Okay, hey, look, Aurora, Miss Barber's not going to actually beat a clock. That's just another one of our idioms. It just means that when you have a deadline, you're trying to get done before the deadline actually gets here. But you have been a little more irritated than lately.
Watch it, Walker. I am not the one who used a malfunctioning ventilation system as a punching bag.
Engineer Walker, you reported the external damage to the secondary ventilation system handler was due to an accidental impact with a diagnostic toolset carrier. Should I amend the incident report you filed with NASA?
No, she was just kidding, Aurora. Weren't you, Specialist Barber?
I'm so sorry. I don't happen to remember that incident very accurately. Perhaps somebody's dessert ration will help me remember it a little more clearly.
Now that's low, even for you.
Specialist Barber, Engineer Walker, it's great to see you again.
Hi, Commander Collins, how are you?
Well, what's new at Spacegate Station?
Nothing really. I was just telling Engineer Walker about our Space Monopoly game that we've been playing.
That is right. You had just landed on my colony on Jupiter just before I left. I have 2 domes on that property. That's going to cost you big.
Engineer Walker, you wanted me to remind you that you are scheduled to record the instructional lesson on gravity and orbits for Dr. Carafano.
That's right. You promised Dr. Carafano that you would record those lessons for him. After all, he is delayed coming back from the lunar colony.
Yeah, I know. And I said I'd be ready, and I will be ready on time. Hey, Aurora, what time is that scheduled for that instruction?
Engineer Walker, you are presently scheduled to do the instruction in 3 minutes and 32 seconds.
I'm not ready.
Engineer Walker, you know what? I could do this lesson for you. I've taught this material for Dr. Carafano back on Earth. I'm sure with Aurora's help, as well as Specialist Barber, we could cover the material for the students. And after all, you know how much I love talking about math.
That would be great. I'd really appreciate that. Aurora should have all the necessary support material in her database. And while you're doing that, I can be going around looking to knock out some of these dents that have been somehow put in the secondary ventilation system.
Commander Collins, I have you set up right at the primary lab station.
Thank you. Specialist Barber, would you like to do the honors of introducing me?
Sure. Sounds good.
Specialist Barber and Commander Collins, I am now recording.
Welcome, students, to Spacegate Station. I'm Specialist Barber, the Chief Communications Officer here on the station, and with me is Commander Collins of the spaceship Defiant. Today, Commander Collins is going to tell us about gravity, orbits, how they relate to our space station circling the moon, and then also how math is involved in this process.
Thank you, Specialist Barber.
So where do we begin, Commander Collins?
Well, first, we have to have an understanding of what gravity is. And, I think Aurora would be able to help us out with that. Aurora, could you explain to our students what gravity is?
Gravity is a force of attraction between objects, specifically that the atoms of one object pull on the atoms of another object. When one of the objects is bigger, then it pulls the smaller object towards it. The size of the bigger object determines the amount of pull it has. For example, since the Earth is bigger than the moon, someone jumping on the Earth will fall towards the Earth faster than they would if they were jumping on the moon.
That's pretty neat. Wait a minute, isn't there an equation we can use to calculate our weight on the moon compared to what it would be on Earth?
Well, there is, Specialist Barber. Aurora, could you show our students an equation and an example of it being used?
I would be happy to, Commander Collins. This is the equation for determining your weight on the moon. First, you take your weight on the Earth and divide it by Earth's gravitational acceleration, which is 9.81 meters per second squared. This will give you your mass. You then multiply your answer by the moon's gravitational acceleration, which is 1.622 meters per second squared. For example, a person who weighs 100 pounds on the Earth would weigh 15.53 pounds on the moon.
Wow, that would make you like Superman on the moon. No wonder people like to work on the moon.
Very true. Now, since we are focusing on gravity and orbits as it relates to the Spacegate Station, it's important to have an understanding of how gravity works in space. Aurora, could you describe for the unique nature of gravity in space?
In space, there is very little gravity because the distance between objects are so vast that the force they exert on each other is minimal. Therefore, an object in space, like a person, would still have mass, but their weight would be very small, therefore they would float. This is known as microgravity, which is commonly felt by astronauts traveling through space.
Good, Aurora, but please explain, how does that impact the Spacegate Station?
The Spacegate Station is traveling or orbiting around the moon. There are two forces involved that act on the space station to keep it in its orbit. First, gravity is pulling the space station back to the moon, so technically the space station is falling towards the moon. Second, the space station is being propelled forward and is moving at a constant speed. This forward speed, or velocity, combined with the fact that the moon is also moving, keeps it from falling into the moon. Although the station misses the moon, it is quickly pulled back by the moon's gravitational attraction and begins to fall again. This constant falling and missing creates a special type of orbit. The path of this special orbit is a curve or ellipse, which is the result of the combination of the two forces. This special orbit is referred to as an elliptical orbit.
That was a very thorough explanation, Aurora.
But Commander Collins, the space station can't stay in orbit forever, right?
Well, that is correct. So space isn't just a perfect vacuum, right? It includes dirt, dust, gas particles that surround the moon. Now, over long periods of time, the colliding of the gas particles, it's significant enough to slow down the space station's orbit.
Oh, so I bet our students want to know how Spacegate Station stays in orbit then, right?
Well, sure. Let's let Aurora help us with that. Aurora, could you explain how our space station stays in orbit?
To remain in orbit, the station must follow a precise elliptical orbit path. Occasionally, the station needs to boost its orbit back to where it should be by using its onboard thrusters. The thrusters need to be operated for a fixed period, which is referred to as burn time. The calculations necessary to determine the burn time to change the orbit of the station require the following information, which is used to calculate the amount of time in seconds the engines need to operate or burn. This information is the present location of the station in relation to the lunar surface, the desired location of the station in relation to the lunar surface, the distance from the present location to the desired location, the present orbital velocity of the space station.
That is correct, Aurora.
So, Commander Collins, how do we get all that information?
Well, Specialist Barber, the first three items on the list require the use of the navigation chart. That helps us identify where we are and where we're going. This is the lunar navigation chart that was made specifically for Spacegate Station. The white elliptical line represents the designated orbit for Spacegate Station. The white dot is where we are in relation to the orbit. On the top and side is the grid systems. They consist of an x-axis, which is the top, and a y-axis, which is the side. NASA uses title boxes or borders along both axes, which include a standard of numbers and letters so that we can identify where we are using a specific location. In the map simulation, the station, which is represented by a white dot, is at position K27. Now, the position we want to be in is on the line, which is directly down from where we are. That position is M27. Now, on any map, on the bottom, you see a scale which shows what each box on the map represents in real-world units. In this case, one square box equals 2,000 kilometers. So based on this map, the distance we need to travel from where we are to where we want to go is 2 boxes, or 4,000 kilometers.
So, is that all the information we need to calculate burn time?
Well, no. So we need one more piece of information, and that's determined by NASA using very powerful radio telescopes. The information is how fast we're going over the space orbital velocity in space.
Okay, so once we get that, what do we do?
Well, we need to determine the amount of time the engines must take in order to conduct the boost maneuver. Aurora, could you describe how the burn is conducted?
I would be happy to, Commander Collins. The following equation is used to determine the burn time to produce the necessary thrust to place the station in the desired orbit. The total distance that the station needs to travel, which was observed in the sample lunar navigation chart, which is 4,000 kilometers, is divided by the orbital velocity of the space station as determined by NASA. In this example, the velocity is 7.65 meters per second. The answer is then 523 seconds of burn time rounded to the nearest whole number.
That was very well done, Aurora. Thank you. Now, students, on your paper, you have 2 problems where you can calculate the burn time. After you have watched the video, your teacher will be able to go over those problems with you and explain the answers.
Well, Commander Collins, thank you so much for being here today. I know our students appreciate you and Aurora explaining all about gravity, orbits, how it keeps the space station in orbit around the moon. I hope you can come back again sometime and tell us even more about how math is so important when it comes to living in space.
It will be my pleasure.
Well, Aurora, I think you can go ahead and end the recording now.
I have switched off instructional recording.
That was amazing. That was really well done, Commander Collins. I'm sure our students have a whole new appreciation for the application of math in science.
Well, there is an old saying, in space, algebra can save your life.
You know, my middle school math teacher used to say that to me all the time. So,
Okay, all finished? Good as new. You never know that someone actually hit it. I mean, dropped some tools on the ventilation system. How'd the lesson go?
No problem. It was easier than rolling off of a log.
oh no.
Here we go.
Commander Collins, I am confused. A log is the abbreviation for logarithm, which in mathematics is the inverse function to exponents. That means the logarithm of a given number x is the exponent to which another fixed number, the base b, must be raised to produce that number x. I do not see how one can roll off a mathematical function.
No, Aurora. I was talking about a log of wood.
Oh no.
Oh, too late.
Processing. A log of wood is a part of the trunk or a large branch of a tree that has fallen or been cut off. To roll off a log of wood would require an individual to be participating in a log rolling activity. Log rolling is a sport frequently used in lumberjack competitions involving two competitors, each on one end of a free-floating log in a body of water. The athletes battle to stay on the log by sprinting, kicking the log, and using a variety of techniques as they attempt to cause the opponent to fall off. I am confused. Neither you or Specialist Barber have access to either a log or water in the laboratory module. In addition, neither of you are wearing flannel shorts, which seems to be a requirement. Although Specialist Barber does have flannel night clothes, although she is not wearing them at present.
Aurora, didn't we already have a conversation about sharing too much?
No, Aurora. Commander Collins was using another idiom. It simply means that something doesn't require very much effort.
I will record that idiom for future use, Engineer Walker. Thank you for the clarification.
You're welcome, Aurora.
Well, I need to head back to the ship and finish the offloading. I'm sure we can continue that game of space Monopoly that we started. And believe it or not, I know I have you beat.
Ha! When it comes to space Monopoly, my family's motto is never say die.
Specialist Barber, I am confused. I have over 87 recorded events where you use the word die in a sentence. December 18 at 0740 hours.
I am dying for a cup of coffee.
December 23rd at 0940 hours.
That Oreo was to die for.
January 5 at 1420 hours.
I would rather die 1,000 deaths.
You two are going to kill me.
January 8th at 1720 hours.
I think the static is dying down.
January 12th at 1123 hours.
Only the good die young. No, please put me out of my misery.
January 15 at 0830 hours.
Cross my heart and hope to die.
This concludes episode 6 of Spacegate Station. Feel free to access our other recorded episodes for student instruction in STEM-related topics. Transmission terminated.